Morning students, in the previous class, that is class 4 of the chapter electrochemistry, I completed. That is Coulomb's law, that is law of independent migration of ion, application of Coulomb's law, that is 3 applications are there. Point 1, calculation of molar conductivity of an weak electrolyte at infinite dilution. Point 2, calculation of degree of dissociation or degree of ionization. Third one, calculation of dissociation constant. Next, Galvanic cell, the construction, observation, working, the salt bridge, function of salt bridge. And in class 5, that is today, of the chapter electrochemistry, I will try to complete. What is the difference between electrochemical cell and electrolytic cell? What do you mean by electrode potential, oxidation potential, reduction potential, standard electrode potential, cell potential, or EMF of a cell? Then what is electrochemical series or activity series and application of electrochemical series? So before starting the today class, let us recap a little bit about the previous class, that is class 4. First one, that is most important thing, I repeat again, most important thing is that is equivalent conductance and molar conductance increases with increase in dilution, while specific conductance decreases with increase in dilution. What is the Coulomb's law? That is the law of independent migration of ion, and it is strictly for weak electrolyte. This law states that the limiting molar conductivity of an weak electrolyte, that is, the molar conductivity of an weak electrolyte at infinite dilution is equal to sum total of limiting ionic conductivity of cation and anion, and each multiplied with the total number of ions that is present in one formula unit of the electrolyte. Then its 3 application is there. First application is calculation of molar conductivity of weak electrolyte at infinite dilution. Second one, calculation of degree of ionization. Third one, calculation of dissociation constant. Then what is galvanic cell? Electrochemical cell or galvanic cell? It is a device in which chemical energy, chemical reaction, that is indirect redox reaction takes place, resulting in the formation or decrease in free energy converted to electrical energy. That is known as electrochemical cell or galvanic cell. It consists of 2 half cells, left half cell and a right half cell. Left half cell, that is containing 1 m zinc sulfate solution where zinc rod is immersed. Another half cell is containing 1 m copper sulfate solution in which copper rod is immersed. Both are connected to external connecting copper wire. Here copper is positively charged, that is cathode, anode, that is zinc, is negatively charged. So next, what do we observe? When cell is complete, reaction is, connection is complete, we observe that the mass of the anode, that is zinc rod, gradually decreases. The mass of the cathode, that is copper rod, gradually increases. The concentration of left half cell, that is zinc half cell, concentration of zinc ion increases, that of copper ion decreases. And both the 2 half cell connected externally by connecting wire, while internally by U-shaped glass tube made up of inert electrolyte along with agar-agar gel, gelatin and agar-agar gel. That is known as a salt bridge. What is a salt bridge? That is a U-shaped glass tube containing inert electrolyte. What do you mean inert electrolyte? The electrolyte not participate in the cell electrode reaction and also with the electrolyte. What is the function of salt bridge? Very, very important one. That means point 1, it connect the two half cell. Point 2, it complete the cell circuit. Point 3, it allow only the transference of ion but not electrolyte. Point 4, it maintain the electrical neutrality between the two half cell. Point 5, it check, prevent liquid junction potential. It is all about the previous class, class 4. So today now move to the class 5 subject. That is point 1 is difference between electrochemical cell and electrolytic cell. Mark that. Left side electrochemical cell, right side electrolytic cell. Mark that. Point 1. Always while giving the distinction, while discussing about distinction difference, we go through the definition. What is the definition of electrochemical cell? It is a device which convert chemical energy to electrical energy. On the other hand, what is electrolytic cell? It is a device which convert electrical energy to chemical energy. Point 1 is definition. Point 2, that is in case of electrochemical cell, the cell reaction is spontaneous, cell reaction is continuous, while in case of electrolytic cell reaction is non-spontaneous. Mark that. Point 2, here the cell reaction is spontaneous. Point 2, here the cell reaction is not spontaneous. Next point, point 3. In case of electrolytic cell, two type of electrolyte are taken. In case of electrochemical cell, two type of electrolyte are taken. While in case of electrolytic cell, one type of electrolyte is taken. Mark that. Here, two types of electrolyte are taken. Here, only one type of electrolyte is taken. Next point, fourth point. The two electrodes are suspended in two different containers for electrochemical cell, but here two electrodes are suspended in one container. Mark that. Here the two electrodes are suspended in different container. Here two electrodes are suspended in one container. Next point. In case of electrochemical cell, anode is negative, cathode is positive. Very, very important. In case of electrochemical cell, anode is negative, cathode is positive. Where in case of electrolytic cell, anode difference is there. That is, anode is positive, cathode is negative. And the last point is, in case of electrochemical cell, salt bridge is used. While in case of electrolytic cell, no necessity of salt bridge. It is the difference between electrochemical cell, that is a galvanic cell, and electrolytic cell. Next, we discuss about another term, that is electrode potential. Next we discuss another one term, that is electrode potential. What do we mean by electrode potential? The tendency of an electrode to lose or gain electrons. The tendency of an electrode to lose or gain electron when it is came in contact with its solution of its own ion, that is known as electrode potential. I repeat again. The tendency of an electrode to lose or gain electrons when it is came in contact with its solution of its own ion is known as electrode potential. It is of two types. One is known as oxidation potential, one is known as reduction potential. Mark that. Two types is there. Point one is oxidation potential. Point two is reduction potential. Oxidation potential symbol is EOX, reduction potential symbol is ERED, electrode potential symbol is E. First we discuss one by one. What is oxidation potential? The tendency of an electrode to lose electron, the tendency of an electrode to lose electron is known as oxidation potential. Symbolically it is represented as, mark that, metal atom, solid, loses n electron to form metal ion. Metal atom loses n electron to form metal ion m to the power n plus. This is known as oxidation potential. Similarly, the tendency of a metal atom to gain electron is known as reduction potential. Symbolically it is represented as metal n plus aqueous plus n electron give rise to metal solid. It is known as the mathematical expression for reduction potential expression, and it is for oxidation potential. So electrode potential is of two types. One is oxidation potential, one is reduction potential. Then we discuss what do we mean by standard electrode potential. Next we discuss standard electrode potential. Symbol is E naught. What do we mean by standard electrode potential? When the electrode potential recorded at a standard state. When the electrode potential is recorded at a standard state. What do you mean standard state? That is, temperature is 25 degrees Celsius or 298 Kelvin, and concentration of the solution is 1 m, 1 molar. Then the electrode potential is known as standard electrode potential. On the other hand, in case of gas, the condition is 1 atmospheric pressure and temperature is 298 Kelvin. That is known as standard electrode potential. It may be again two, that is standard oxidation potential and standard reduction potential. Next we discuss what do you mean by cell potential or EMF of a cell. Next we discuss that is cell potential or EMF of a cell. Symbol is E cell. What do you mean by cell potential? The difference in potential value of the two half cell. The difference in potential value of two half cell electrode reaction. This is known as cell potential. I read again. The difference in electrode potential value of the two half cell is known as cell potential, and it is known as electromotive force. The cell potential is known as EMF, electromotive force of a cell when no current is drawn from the cell. In other words, electromotive force is also defined as a force which causes the flow of electron from one electrode to other electrode, as a result of which there is a flow of electron, means flow of current. Normally, we know that a galvanic cell or electrochemical cell is made up of by the combination of two half cell, anode half cell and cathode half cell. That's why the cell potential, that is EMF of a cell, also calculated by sum total of two half cell electrode potential. Symbolically, it is represented as, in other words, symbolically it is represented as E cell is equal to, or standard cell potential or standard electromotive force of a cell, that is inert cell of anode, that is taking place, that is oxidation, plus that is inert cathode, that is reduction. Again I repeat, since the electrochemical cell is based upon the combination of anode and a cathode, and we know at anode oxidation takes place, at cathode reduction takes place. So the standard cell potential is also equal to the sum total of standard oxidation potential of anode and the standard reduction potential of the cathode. It is one way to represent the EMF of a cell or standard EMF of a cell. In other words, also it is also expressed in different way, another two different way. One is both the half cell potential is expressed in terms of oxidation potential and both are expressed in terms of reduction potential. Mark that how it is. The second way, that is inert cell is equal to inert of anode, that is oxidation, minus inert cathode, that is oxidation. The second method. Third method is the inert cell is equal to inert cathode reduction minus inert anode reduction. The three different ways there, but result is one. Three different way. One to calculate the EMF of a cell. So, but remember that among the three different ways, always we select the third one, that is reduction potential of cathode minus reduction potential of anode. 2 to 3 points are there, mark that under the heading of note. 2 to 3 points are there. That is, oxidation potential is equivalent to the negative of reduction potential. Mark that. E naught ox is equivalent to negative of E naught red. Similarly, E naught red reduction potential is equal to negative of E naught ox. That is, loss is equal to minus of gain, gain is equal to minus of loss. Second point. Third point. The absolute value of an reduction potential, absolute value of an oxidation potential of single electrode cannot be calculated. Next point, that is electrode potential, that is maybe oxidation potential or reduction potential, may be expressed in terms of unit is volt. Next, for calculating the half cell value, oxidation potential value, or calculating the single electrode potential value, it is necessary to join with another one electrode, that is known as reference electrode. And here, the NHE, normal hydrogen electrode, or SHE, standard hydrogen electrode, is taken as reference electrode. And arbitrarily, whose electrode potential, whose reduction potential is taken as 0 volt. It is all about the oxidation potential, reduction potential, standard electrode potential, cell potential, EMF of a cell. Then we discuss another one, that is activity series or electrochemical series. Next we discuss electrochemical series. Electrochemical series, otherwise also it is known as activity series. It is already over in previous class 3 or 2. What do you mean by electrochemical series? Experimentally, all electrode potential value, maybe oxidation or maybe reduction potential value, can be calculated. So if this electrode potential, the reduction potential value of all the elements are arranged in increasing order of their reduction potential, then the series obtained, that is known as electrochemical series or activity series. I repeat again. The arrangement of reduction potential of different element in increasing order of their reduction potential in a series is known as electrochemical series or activity series. Then we discuss what are the application of electrochemical series. Next we discuss application of electrochemical series. Four to 5 points are there under the heading of application. That is, point 1, predict anode and cathode from the electrode potential value, from the oxidation potential or from the reduction potential value, how we calculate which one is anode, which one is cathode. Second one, calculation of cell potential, how we calculate EMF of a cell. Third one, to predict the feasibility of the cell reaction. That means whether the cell is feasible or not, means whether the cell is working or not. Next point is to check the reactivity of the elements. That means which element is more reactive, which element is less reactive from their reduction potential value. Next, to predict whether a metal reacts with sulfuric acid, liberate hydrogen gas or not. And last one, to compare the oxidizing property or reducing property. Let us discuss one by one. First one is to predict anode and cathode. First one is to predict anode and cathode. Mark that. Two metals are given in the data in the question having their oxidation potential or reduction potential. No restriction is there. We have to observe whether oxidation potential or reduction potential data is given. If reduction potential data is given, no problem. If oxidation data is given, then multiply minus sign, as a result of which oxidation potential is converted to reduction potential. Then two data are there in the reduction potential form. Mark that which one possesses lower reduction potential. That one is anode, while higher reduction potential is known as cathode. I repeat again. Lower reduction potential, the metal or the element possess lower reduction potential is behave as anode, while the metal possess higher reduction potential. Higher reduction potential behave as cathode. Let us apply this concept to solve a problem. Mark that. Data given, that is two half cell reaction data is given. Mark that. That is E naught Zn2 plus slash Zn is equal to minus 0.76 volt and E naught Cu2 plus slash Cu is equal to plus 0.34 volt. This is the data given. Question is we have to predict which one is cathode, which one is anode. So first thing, we have to check whether the data, electrode potential value data, is in the oxidation potential both or reduction potential both or one oxidation, one reduction. Mark that. That is ion transfer to atom. Ion transfer to atom. That means it is a reduction potential. Both are in a reduction potential form. Then mark that which one is a lower value. That means this is a negative value, it is a positive value. It is a lower value, behave as anode. It is a positive value, behave as cathode. One thing remember that in the question, it is not necessary, it is not compulsory that both the data are in reduction potential. Maybe oxidation, maybe reduction. Our aim first to change the data to reduction potential value. Next, mark that which one is lower, that is known as anode, which one is higher, that is known as cathode. Move to the second application. to calculate EMF of a cell. The second application of electrochemical series, that is to calculate the EMF of a cell. How we calculate the EMF of a cell? Just before we completed one formula is there, that is how we calculate the cell potential or EMF of a cell. By a formula, the pseudo formula in form of reduction potential, that is Anode cell is equal to Anode cathode, that is reduction, minus Anode anode, that is reduction. So one important thing is that we have to find out 2 points. Which one, 2 different metal atoms are given. Which one is anode, which one is cathode. Point 2. Whether it is oxidation or reduction going on. Then only we apply this formula. First thing, mark that. Data is given. Mark that. Question. Let us apply this concept. Means by the help of this formula, how you solve one equation. Calculate the EMF of a cell from the following cell reaction. That is zinc plus silver ion give rise to zinc ion plus silver. The cell reaction is given, along with given that Anode Zn 2 plus slash Zn is equal to minus 0.76 volt and Anode Ag plus slash Ag is equal to plus 0.80 volt. This is the question. Our aim to first find out which one is anode and which one is cathode, and whether it is oxidation potential given or reduction potential given. So from the cell reaction, mark that zinc converted to zinc ion means here oxidation takes place. Silver ion converted to silver means reduction takes place. It is clear that oxidation takes place at anode, reduction takes place at cathode. So here zinc behave as anode and silver behave as cathode. Point 1 is over. Answer. Point 1 is over. Which one cathode and which one anode. Then switch over to the reduction potential or oxidation potential that I given. Mark that. Here ion transfer to atom, here ion transfer to atom. That means both are in a reduction potential form. Then the simple answer, apply this formula, that is cathode reduction minus anode reduction. Which one is cathode? Silver. What is the reduction potential? That means 0.80 volt minus, which one is anode? Zinc is anode. What is the reduction potential? Minus. So minus of minus 0.76 volt. That is 0.80 plus 0.76 is equivalent to 1.56 volt. This is the value of cell potential or EMF of a cell. I remind again, We have to, before applying this one, we have to go through 2 points. That is, to check which one is anode, which one is cathode, and second one, whether oxidation potential data is given or reduction potential data is given. Next we have to third application, to check the feasibility of a cell. Third application to check the feasibility of a cell. What do we mean by feasibility? Means possibility. Means whether the cell reaction proceed or not. That means whether the cell works or not. How it is possible? Mark that. From the data, same thing is there. We have to predict which one anode and a cathode. Whether oxidation potential or reduction potential data given. Then only apply the formula, that is E naught cell is equal to E cathode reduction minus E anode reduction. By applying this value, mark the answer, whether it is positive or negative. If cell potential is a positive value, if EMF of a cell is a positive value, then cell is feasible, means cell functioning, cell work. On the other hand, if the EMF of a cell is negative, that means the cell does not function, cell is out of order. I repeat again. Point 1 is, if the EMF of a cell is found to be positive, then the cell is feasible. On the other hand, if the EMF of a cell is found to be negative, then the cell is not feasible. Let us apply this concept for solving problem. Mark that. One problem is there. Then we have to check whether the cell is feasible or not. Question: check the feasibility of the cell reaction. Point 1. Zinc plus copper sulfate give rise to zinc sulfate plus copper. Point 2. Copper plus zinc sulfate give rise to copper sulfate plus zinc. The data given that E naught Zn2 plus Zn is equal to minus 0.76 volt and E naught Cu2 plus Cu is equal to plus 0.34 volt. Mark the question. Two equation is there, two cell reaction is there. We have to check which one is correct, which one is not. Which cell reaction is correct means which cell is functioning, feasible, which one is not. So try one by one answer. Mark that. If this is the cell reaction, we rewrite that bit one. We rewrite that zinc plus copper ion give rise to zinc ion plus copper. Mark that. Cancelling sulfate ion in both the cases. Zinc plus copper ion give rise to zinc ion plus copper. Mark that. Here it is clear that zinc undergoes oxidation, copper undergoes reduction. So zinc behave as anode, copper behave as cathode. So putting this value, we have anode cell, that means anode cathode, red means reduction value, minus anode red means reduction value. Here cathode, I repeat again, cathode is copper, reduction value given, anode is zinc, reduction value is given. That means 0.34 volt minus of 0.76 volt. This is equal to 1.10 volt. That is positive. It indicates that a cell reaction is possible. It indicates that a cell is feasible. On the other hand, move to the second one, mark that. From the second reaction, it is clear that the cell reaction may be represented as copper plus zinc ion give rise to copper ion plus zinc. So here oxidation takes place, here reduction takes place. So copper is behave as anode, while zinc is behave as cathode. So if we apply this concept to calculate anode cell is equal to the reduction potential of cathode, that means minus 0.76 volt, minus reduction potential of copper, that is 0.34 volt. Mark that, answer is negative. Hence it is clear that the second case is not feasible. Means copper never displaces zinc from zinc sulfate solution forming copper sulfate solution. Let us apply this concept for solving another one problem. Move to another one question. The question is, a cell is built of by taking a cell is built up by taking 1 m copper sulfate solution and 1 m nickel sulfate solution. We have to select two electrolyte, that is copper sulfate and nickel sulfate, in which copper electrode is inserted in copper sulfate solution, nickel electrode is inserted in nickel sulfate solution. Mark that. A cell is built up by taking two electrolyte, one is 1 molar copper sulfate solution and 1 molar nickel sulfate solution. Nickel, that is copper electrode is suspended in copper sulfate solution, and nickel electrode is suspended in nickel sulfate solution. Then calculate point 1, the cell potential represent the cell reaction. Next, predict which one cathode and anode. Next, predict which electrode is negatively charged and which is positively charged. Mark these are the question data given. These are the question. We have to predict 4 points. We have to find out the four answer. One is the cell reaction. Cell reaction. One is to calculate EMF of a cell. Next, we have to predict which one is a cathode and which one is anode. Next, we have to calculate which is negatively charged, which is positively charged. Last one also we have to calculate. Another one bit is there. We have to represent the cell notation. We have to find out these 5 bits. Let us discuss one by one. What are the data given? 2 metal electrode. For solving this one, to data is also given. That is another one thing given that E0 Cu2 plus Cu is equal to plus 0.34 volt. Another one is that is nickel E0 Ni2 plus nickel ion slash nickel is equal to minus 0.25 volt. These are the data given in the question. How we solve this bit one by one. Mark that. From this data, it is clear that both are reduction potential. From this data, it is clear that both are reduction potential. And second thing is that it is a higher reduction potential, it is a lower reduction potential. So it is clear that here copper electrode behave as cathode and nickel electrode behave as anode. The most important thing is that how you know? From the reduction potential value, which one possesses higher reduction potential, that is known as cathode. Which one possesses lower reduction potential, that is anode. So here nickel is anode and copper is cathode. Next is in case of electrochemical cell or galvanic cell, that is anode is negative and cathode is positive. As it is a cathode, it is positive, and as it is anode, it is negative. Then we have to calculate the cell potential, Anode cell, bit 1, bit 2. Anode cell is equal to reduction potential of cathode. What is the reduction potential of cathode? 0.34 volt minus reduction potential of anode minus 0.25 volt. That means 0.34 plus 0.25 is equal to 0.59 volt. This one is the EMF of a cell or cell potential. Next, we have to calculate. Next, we have to represent the cell reaction and we have to represent the cell notation. As left hand side, in case of galvanic cell, left hand side is the anode half cell, right hand side is the cathode half cell. So first we represent anode, that is nickel Next bit is cell representation or cell notation. Cell representation. Which one is anode? That is nickel. Nickel solid / nickel ion. Concentration 1 molar. It is a salt bridge. Then cathode. Copper ion in aqueous form. 1 molar concentration / copper solid. This one is anode half cell. This one is known as cathode half cell. This one is negative half cell. This one is positive half cell. This one is oxidation half cell. This one is reduction half cell. It is known as salt bridge. Next bit is cell reaction. Next bit is cell reaction. So anode is, which one is anode? That is nickel. That is nickel plus copper sulfate give rise to nickel sulfate plus copper. It is known as cell reaction because nickel is transferred to nickel ion, that is loss of electron, that is oxidation takes place at anode, and copper ion transferred to copper, that is reduction takes place at cathode. So it is known as cell reaction, it is known as cell representation, it is known as EMF of a cell, and here anode is known as nickel, it is negative charge electrode, and copper is known as cathode, that is positive charge electrode. Next switch over to another application, that is reactivity, to predict the reactivity of an element. Next application, that is application number 4. Fourth application, to predict the reactivity, of an element. Mark that. In electrochemical series, in activity series, different elements, their reduction potential value are there, arranged in increasing order of reduction potential. That is negative value to 0, then positive value. So the metal or the element which one possesses lower reduction potential is more reactive, while that element or metal possesses higher reduction potential, it is less active. I repeat again, the element or metal possesses low reduction potential value, is more active, and it displaces another metals from its salt solution. For example, mark that. If the two data is given, that is E naught zinc 2 plus / zinc is equal to minus 0.76 volt, E naught Cu2 plus / Cu is equal to plus 0.34 volt, E naught Ni2 plus / Ni is equal to minus 0.25 volt, and E naught Ag plus / Ag is equal to plus 0.80 volt. This is the data given in the question. By applying this data, let us mark the question. What is the question? Question. Can one molar copper sulfate solution be stored in, can 1 molar copper sulfate solution, 1 molar copper sulfate solution is stored in zinc vessel, mark that, or we can write Can a spatula of zinc is be used to stir 1 molar copper sulfate solution? Mark that. Same data is there, same meaning is there, but different way of representation. That means a container is there. That means a container in which copper sulfate solution is there. Then we have to select one spatula, one spoon, which is made up of zinc metal. So can we stir the copper sulfate solution with the help of zinc spoon? Or container is there, that is known as zinc container. Can we keep a 1 molar copper sulfate solution? So how we solve it? Mark that. If we going through this one, if we obey this one, then what is the cell reaction? Cell reaction is zinc combined with copper sulfate forming zinc sulfate plus copper here, or zinc plus copper ion give rise to zinc ion plus copper. Mark that. Here zinc undergoes oxidation while copper undergoes reduction. So zinc behave as anode, copper behave as cathode. So if we calculate the Anode cell, then reduction potential of cathode and reduction potential of anode. So reduction potential of cathode, that is copper, is equal to 0.34 volt minus is equal to 0.34 volt minus, that is reduction potential of zinc, minus plus 0.76 volt, that is plus 1.10 volt. Means the cell potential is found to be positive, means cell reaction is going on, cell is feasible. That means zinc displaces copper from the copper sulfate solution. That means one is not able to stir the zinc spatula to stir a copper sulfate solution. Another type of question is there. Why blue color of copper sulfate solution? Why blue color of copper sulfate solution get discharged when a spatula made up of nickel is used? Why blue color of copper sulfate solution get discharged when a spoon spatula made up of nickel stir on it? Mark that. Same concept is there. That means predict the cell reaction. The cell reaction is nickel plus copper sulfate give rise to nickel sulfate plus copper. That means nickel here behave as anode and copper is behave as cathode. So applying this value, putting this value to calculate Anode cell. Anode cell is equal to cathode reduction, that is 0.34 volt minus 0.25 volt. This is equal to 0.34 plus 0.3525, that is 0.59 volt. That is positive. That means nickel displaces copper from copper sulfate solution. As long as in the container copper sulfate solution is there, it looks blue. But when copper sulfate transfer to nickel sulfate, blue color disappears.